Okay, this is going to be a video about one of the more advanced tools that's available with Circuit Maker. It's called the transient analysis window, which is a very fancy term for what we normally call an oscilloscope. Oscilloscopes allows you to take and look at signals in the time domain. That is, they show the signal how it varies with time. What I'm going to do is go into Circuit Maker. As you can see my shared screen here, I already got the window open. The workspace is right now blank, so I'm going to take and put some stuff in there. So let's take and grab some devices here. So I guess what I need is I always need a ground, grab a ground, and then we'll take and maybe get a couple of resistors. So let's take, and that's in hotkeys number 2. So let's take a resistor here, and I'll actually duplicate that resistor over here. So let's take and change the value of the resistor. Let's edit that one and make it, instead of a 1K, we'll make it a, let's make it a 200 ohm resistor. Okay, and I'm going to also take and rotate that 90 degrees. So now I'm going to connect it, and we'll go through the normal procedure of connecting here, except for one thing. I really need a signal generator, and I didn't put that into the screen, so let's do that now. Under hotkeys number 1, I believe it's a signal generator, and there it is. And what we'll do is keep wiring. So bring this guy over here and bring this guy down here. I'll try to bring him down there. Come on. And let's spiffy this up a little bit. Move this guy up here. Move him up there. Move this guy up here. Hopefully take and correct this wire here. Persnickety. This guy here, I'll move him over there. So it looks like a regular circuit. Okay, so now I got 2 resistors, a 1K and a 200 ohm, and I've got a signal generator. So when I go and hit the running man this time, what happens is I get this guy automatically comes up. I'm not worried about DC voltages in this circuit, so you know what I'm going to do? I'm going to X that guy out. It's just a distraction. But down here, you might notice that, let's take and move this guy around a little bit, move him up. Down here, you might notice that I've got a grid. And if I go with my probe and put the probe, well, let's go with the output of the signal generator, I get this green waveform, which shows me a 1 kilohertz signal that's 2 volts peak to peak. And, you know, it turns out that, again, I have cursors on my oscilloscope, so I can move one cursor down, that was the C cursor, move the D cursor up, and then up here I see C minus D, and let's move this up a little bit. C to D is roughly 2.016. It's, you know, I could Mickey with it a little bit, and I think I could make it exactly 2 volts. That's close, 2.003. Anyway, that's you know, using the cursor here, I can measure the peak to peak voltage, and I could also measure, say, the frequency. I'll go with A there and move B over to the peak of another sine wave, and I'll see a frequency of you know, 1 kilohertz up here, A to B. The markings aren't too good on the scope. It should be C1KHZ, but instead it's 1K, and over here there's no voltage on C to D. If I click anywhere on the screen, they all become light blue here. So sometimes the red on the black is not too readable, but nevertheless, you know, here let's go back up to the circuit. I put the probe on A. Now, if I put my probe over here, what happens if I click on it? Well, what happens is you know, A is moved from there over to there, and it turns out that now we're looking at the voltage across the resistor R2. Let's go back and move it to there. And let's go over here, but now I hit the shift key. I hold the shift key down as I press it, and now I see 2 signals. So now I can see a dual trace where the yellow one is the voltage across R2, and the green one is the voltage going into the circuit. Actually, if we take and do some simple calculations, we should notice that I got 200 over 1200, or 1/6 of the input voltage should be on the output. And as you take a look at the yellow one, here the yellow trace, you discover it's 1/6 of the size of the green trace. Now, by the way, in the oscilloscope here, I have a lot of controls over here. It usually always comes up automatic, but I do have manual, and I can take and change the scale here. I can take and go in this fashion here, makes the scale go down, or I can expand it so I can make closer, better measurements, or I can take and reduce it that way in time, or expand it in time that way. Again, I can put it in manual mode or auto mode. I think I may have mentioned before, I can blow things up. If I do that, I can go back to the redo, I guess, symbol over here and bring it back. There's another symbol here where I can take and change the axis settings. Right now, both the X and Y axis are magnitude. Say we had frequency down here on the, the X axis, we might want to make that instead of being linear like it is a logarithmic display. Very often when we have frequency, we go many decades in frequencies, so we take and use log as opposed to linear there. In the y-axis, sometimes we look at filters, we want to do magnitude as a decibels or a logarithmic type of value as opposed to a magnitude. And again, there's all kinds of other stuff we could do here. We can bold the waveforms or unbold them. I guess we do that over. I got to get out of here. If I go over here, I can make A bold, or I can make the green one bold. How many waveforms we can see, I think, is pretty unlimited, but after a while, the display would really get too full and be difficult to see stuff. So that's, basically how you use the oscilloscope. If it doesn't come up, you go up to Window, and under Window, you'll see Circuit, Multimeter, which I killed before, and the Transient Analysis Oscilloscope. If it's not there, you click on one of these, and usually it comes back. So let's go and clear this guy out of here. Let's stop this. So we go over and stop it. Let's go to File and say New. It'll ask us if we want to save it. We'll say no. So the beauty of the oscilloscope is that it allows us to take and make measurements like phase measurements. So what I'm going to do here is I'm going to grab, again, we always have to have the ground. I'll grab a ground. This time I hope I'll get the signal generator right away. Here's a signal generator. And what I'm going to do this time is I'm going to get under my hotkeys number 2, I'm going to get a resistor. Here's a resistor, but I'm also going to take and get a capacitor. So let's see where we find the capacitors. Let's go to devices. Let's try hotkeys number 1. Yeah, here's a capacitor. So we'll go down here. Here's a capacitor, and I'm going to put that there, but I'm going to rotate it 90 degrees. And then what I'm going to do is connect these guys together. Get my plus sign up here. Connect like that. Connect like this. Connect like this over here. And let's take and try to clean it up a little bit first. So we'll go like that. Maybe bring this guy over like that. Move this guy in the middle a little bit, not a big deal. Yeah, move this guy down over here, and again here we'll take in, bring that up there. We need that to have this thing work. And I click anywhere to get them all. Now, this circuit, resistor and capacitor, we should know that a resistor has resistance, and resistance is supposed to stay constant at all frequencies, but the capacitor has something called reactance. That is its opposition to the flow of AC current. We know there's no electrons flow through the capacitor, but if I apply an AC signal to this, what will happen is the dielectric material will get affected, and get affected once, well, I should say twice per cycle, when there's one polarity and the other polarity. And depending on the frequency, how it gets affected is different with frequency. So the capacitor is a frequency selected device. So let's take a look and run this guy. We run this guy, again, let's get rid of this DC voltmeter, we don't need it. Let me bring this guy up in the center here. And so I'm gonna go and do what I did before. I'm gonna click the probe here, and I see the input signal. Then I'm gonna click the probe over here. Remember, I gotta hold shift down while I click it. And there I have two signals, the output and the input and the output. What I'm gonna do is I'm gonna go and, let's see what I can do here. I'm gonna take and go to manual, and I'm gonna take and see what happens if I change this. Yeah, here we go. What you might notice is that these two signals are out of phase. That is, the yellow one and the green one don't occur at the same time. So it turns out that, let me drag this up here, get rid of that for a second and drag my oscilloscope up here, make it bigger. Another thing is you might notice where it starts over here, it takes a while before the yellow one, which is the output, comes all the way down here. So what's happening is there's a transient transient effect that it takes about 5 waveforms before things settle down. I'm gonna go and see if I can bring this down again. So again, here you see the peak of the yellow one, not when the peak of the green one is occurring someplace up here. And I can offset, I believe. I see offset, it's not highlighted. So let's go, if I take and go back to automatic, how do I do offset? I'm not seeing how I can take an offset. Maybe I take in bold one. And now if I do offset, how do I go about offsetting? Probably with this. Here we go. So it turns out now you can definitely see there's a phase shift. Of course, reactance and resistance together in a circuit give you a phase shift. It turns out that, again, it takes time for the capacitor charge and discharge. And what happens is the voltage through, let's go back to the circuit here and see which one is which. The green is the input, I believe. Let's drag the circuit down. Yeah, the green's the input and the output is the yellow one. So what's happening here, if we take a look, is the yellow one is lagging the input. So the voltage that is on the output across the capacitor there is lagging the voltage from the input. So we have a phase shift. How we can figure out what the phase shift is we can see that there's 360 degrees from here to here, and we can see how many, what's the delay in time. So we can measure time and figure out what the, if the time from here to here is some value, if the time from here to here is 1/6 of that, be 1/6 of 360 degrees. And we can figure out phase shift that way. So we can measure phase shift with this transient analysis tool, the oscilloscope. If we take and we had something like an amplifier, what happens, we want to take a look at the signal at the input and the signal at the output. In the experiment depending on what the experiment is, you have to look at the output of the signal generator and the output, across, say, a load resistor at the output of an amplifier. And again, you'd have two different colored displays, and one's the input, one's the output. You can figure out gain and do other calculations. So that's about it for this little talk about the oscilloscope.